Hi. So hello, everyone. My name is Neal Gompa, and I'm here to talk to you about grading content collections for CentOS SIGs. So there is a lot of things about me on here. This is a lot of bullets. Put it simply, like my day job is I'm a consultant at Velocity Limitless, my consulting firm, but I also contribute to a number of Linux distributions, as well as a variety of open source projects in both code capacity or mentorship, leadership, directions, project planning. I also am involved in KDE as well as in Wayland and all these other related stuff. And I'm a co-host of the Pseudo Show where I talk about open source, business, and all that other fun stuff. So let's talk about CentOS SIGs. So CentOS special interest groups are a part of the whole CentOS project in the sense that CentOS project itself is essentially split in two. You have the core group from Red Hat Enterprise Linux Engineering that develops the CentOS Stream distribution, and then you have everyone else. And everyone else is, there'll be the Infra SIG, as Fabian was this morning, Hyperscale SIG, as David and I earlier, there's automotive, there's K-mods and virtualization and all these other special interest groups that have different functions and provide additive content for CentOS Stream. So SIGs operate on the principle that they provide something to make CentOS Stream more interesting to use on top. And so how this kind of looks, and this is kind of a little bit in the weeds, but also I think kind of helps illustrate what I'm talking about here. So this is from the Hyperscale 10, one of the tags for, or the build environment setup for one of the Hyperscale build tags in CBS. And for this, you can see we have all these Hyperscale segmented content repositories being pulled in through the inheritance. But you'll notice that the external repos, we have the CentOS Stream stuff and Fedora extra packages for Enterprise Linux. And this allows you to kind of see where the divide is in terms of what stuff SIGs are able to do things with versus ones that can't. Things listed as external repos are effectively treated as immutable. You can't really do anything about it. You kind of have to just react and respond to when they change because it's not up to you. Whereas the stuff that's in the tags is the stuff that in the normal inheritance model that you can actually control, which comes in and out. Even if it's a tag from another team pulled into your inheritance, you can exclude content from that or inherit it or whatever. So you have more fine-grained control over the stuff that you have, and then you just kind of have to take what you get from the external content sources. So there are two big problems that kind of come out of this when you especially have SIGs that consume lots of independent sources or interdependent content sets. The SIG content in CBS Koji can change and publish at any moment based on the activity because everything is instantaneous. Everything kind of happens immediately. And the content pulled in by CBS Koji, the community build service, to expand on that, will change on a schedule that you don't get to know. Well, in practice, you get to know for like EPEL. For CentOS Stream, you kind of sort of know because you know that that they're doing these collections, these composes on a regular cadence. You don't actually know when those composes are actually going to go out because that part is sort of invisible. And so you just kind of have to accept it coming in. So that's the content integration part shifting all the time. And then you have issues with when you want to create test cases and reproducibility and things like that. When you are trying to isolate a problem that you are seeing, you want to constrain or simplify the variables. You also want to be able to lock down the inputs so that you have some kind of way of describing what is the state of the world that creates or fixes a problem and be able to prove it. And in the ways SIGs are able to function today, this is not really possible because SIG content is not strongly linked to the content that they build on top of. So when something gets built and shipped into a SIG repo, the relationship to the content that it came from is gone. And therefore, when you install it, for example, you don't know whether whether the nature of the problem was caused by you or the nature of the problem was caused by the thing you were built on top of or whatever, because you just don't have a way of proving it. And this kind of leads into the second point, which is that a complete collection that kind of shows the full set of inputs that release to create the outputs is just not available to you. So we'll jump quickly to Fedora for a second. I promise this is important. So Fedora differs from CentOS in a couple of key ways. The first way is that everyone is involved in the production of the Linux distribution. For the purposes of our discussion, there are two major parts of it. There is the Fedora Linux distribution, and then there's the extra packages for enterprise Linux repository. EPEL is not interesting for the purposes of discussion because it's basically the same problem domain that we're talking about right here. But Fedora Linux is interesting from this problem domain because it is entirely self-contained as a discrete content set. When things go out and they get pushed as updates or whatever, you have a strongly linked case of where things churned or changed, and you can prove these things because you have these content collections that Fedora calls composes. And these composes are essentially release engineering tooling goes and pulls all the things that happened and then puts it together into one big blob of stuff and pushes it out into a folder. And then that is then used as an input for testing. So OpenQA, for example, will take a compose directly and start producing artifacts or testing artifacts or both, depending on what kind of the test cases are. So for example, in Fedora's OpenQA, we take the artifacts that were produced by Koji and then run them through a battery of tests, but then we also have some tests that test the cases that Koji itself runs. So for example, there's a test case to produce a live image to make sure that the live image tooling doesn't break as part of an update, because that's important. You really don't want that tooling to break between releases of these composes. So coming back to CentOS and talking about what that means for us. The CentOS Hyperscale SIG operates quite a bit differently from most of the other special interest groups in CentOS, with the notable exception of automotive. Special interest groups in Fedora, and I guess now the Cloud SIG because of the SCOS thing that happened yesterday. CentOS Stream CoreOS is, I think, what I'm supposed to say there. So with exception of the Cloud SIG with CentOS Stream CoreOS and the automotive SIG with the CentOS Stream automotive distribution, you don't really see SIGs needing to care about the link between the base components and the layered components in a way that they can have verified testability. Like that's not important to them because they don't deliver an artifact. Like when the virtualization SIG was building overt, it was an important factor for them, and they actually built out secondary infrastructure for this. When RDO was doing more stuff inside of CentOS, they were also doing this. Neither of those projects do things in CentOS infrastructure in this way anymore, and so they're out of scope. I mean, their problems are still there, and they're still real, but they either solve them differently or they don't care about them. So for CentOS Hyperscale, you essentially have to start thinking of us like, well, okay, we're basically operating in the same sense of a Fedora Linux, where we effectively want to create this relationship of a strongly linked set of content between all the different layers and treat them as one testable unit for whether it's validation, release engineering, or any number of reasons. So this is where a tool that we've been developing for Hyperscale and hopefully will be useful to other SIGs called Kurchu, which is a tool to assemble Fedora and CentOS resources to create artifact collections. So essentially the same thing that Punji does in Fedora for composes. If you're familiar with Punji, naming a Punji, it charms anacondas to do things, whatever. But like, It used to automate Anaconda. That's what it used to do. So that's why it's named that. But Punji is used to talk to the various services within Fedora to collect the content, to orchestrate the creation of image artifacts, pull them in and integrate them into the set, and then push them out to testing. And if they pass the testing, then push them out to the mirror network. In some sense, this is what we're attempting to re-implement with Kurchu in a slightly different fashion and more tuned towards the use case of, well, we're trying to integrate these disparate things that already have their own stuff and provide another layer on top of integration. So for Kurchu, it's basically defined with a TOML. Sorry if it's too small to read. It's actually quite hard to make that fit and look semi-reasonable on a slide. But the idea here is that unlike Punji, which uses semi-programmatic declarative configuration, which scares me, I decided to kind of go a fully declarative approach using TOML with some templating, very, very restricted templating that allows you to define what your inputs are going to be and how you're going to transform and then publish the outputs. So this is a TOML configuration file for a CentOS Hyperscale 9 compose, which results in something like this. So just a few days before we all got ready to come here, David and I got kind of our first compose that worked up on this site, hyperscale.sig.centos.org. So hyperscale.sig.centos.org is a resource sponsored by Meta for the Hyperscale SIG to be able to host these testable units. And I went into a folder to kind of show this. This is, you can see this base extras, EPEL stuff, Hyperscale. And if you go back to this description here, you may not necessarily be able to read it, but I promise you it's there, is that we list the hierarchy that we are constructing for this ultimate output inside the definition. So we don't really make assumptions about the structure. You get to define the structure as you please. This is another big difference from how it works for other compose tools that are used in the Red Hat world. So like ODCS, which is the on-demand compose service used for CentOS Stream itself, and Punji, which is used by Fedora, and Bodhi, which people don't know this, but Bodhi actually makes composes all by itself. It is a re-implementation of Punji inside of an update manager. So, yay. So those all have much more fixed and inflexible ways of operating this. And this was actually one of the reasons we didn't reuse Punji, was because if you tried to do this with Punji, what you would get is a one big flat hierarchy of stuff. And you wouldn't be able to preserve things like how is the ordering, the inheritance, the override model, and things like that. Those are all things we want to preserve because we want to be able to test the unit as we actually want it to be shipped. And that is not easy to do with Punji, as it is not designed to work that way. And I couldn't find enough people to explain to me how Punji's internals actually work to see if it would even be possible to make that do it. So a big part of why I wrote this was no one knows how Punji works, and that is a very big problem. And I spent a lot of months last year actually doing a lot of Punji-related work as part of the Fedora cloud move to using Kiwi images and things like that. So I learned that almost everyone else also doesn't know how this works, and we're all just hitting hammers until it works, which is not the experience I want to have for this. But yeah, kind of coming back to this hierarchy gives you a very easy way to understand, a very easy way to like structure things. And we kind of want to drill into this JSON file. And again, I apologize if you can or can't read this, but it basically is the result output form with all of the value substitutions and things like that in place here. But another extra property that isn't in the in source is that, so for example, we have in the TOML, we say, okay, we're going to pull the latest composes of all the things, and then we're going to use that to create a testable unit. This artifacts JSON actually resolves all those latest to their exact inputs. So for example, the Punji compose and the ODCS compose and the Bodhi composes, or the Koji dist repo versions that were actually pulled in, so that if you used this JSON file, you could read out, you could actually push it back into the tool to do it again, provided that the resources are still there where they originally were. I personally wanted this because I didn't want to have to figure out how to parse all of the different ways that all the different tools that I'm consuming store their metadata. So I just wanted to pull the relevant parts of the metadata and incorporate them into this file so that you only have one place and one standardized format to pull it in. Because like Punji puts it out in a config parse, a bastardized config parser format. ODCS uses JSON, and Bodhi just uses a value in a text file, and like it's not a particular format. And I just didn't want anyone to suffer through trying to parse all the different metadata, and just made one that has the important parts. If you want to go read all the other metadata, we actually import all of them too. They're in the compose artifacts, but you don't need them. That's why it's kind of set up that way. So the current state of Kurchu and the release plans. At this point, Kurchu development is, well, is gratefully sponsored by Meta to support all this stuff. It is also being done in tandem with the development for CentOS Stream Hyperscale 10. So a lot of the bring up work that we've been doing, part of the reason that it's kind of gone slower than it did when we were doing CentOS Stream 9 is this time around, I am trying to put everything into, write everything down and figure out what pieces matter and put that into a form where we can repeat this again and again and again and again, because I want to make the next round go faster, because we're doing this every 3 years and the treadmill does not get easier. So having a way to minimize the amount of human grunt work steps for producing releases is useful for validation, for testing, for integration, and even for development. So I want to have this in this for these steps. At this time, Kurchu can gather all the repos, and it can produce the metadata of the collection, and it can publish them either to a local mount point directory for being to a regular web server, or to S3. I mean, other targets can be added because the internal code structure supports more targets, more things, whatever. The remaining thing to do for the initial release is to get it to be able to orchestrate producing hyperscale spin images and container images, because I want this, we need to replace a bunch of aging automation for image releases in Hyperscale, and this is kind of where I want to put that stuff. There's also another aspect of this design which I didn't really note, but is I think kind of important and will make it more useful for other SIGs. Each of the steps that are done in here can be omitted, and it's fine. So if for example, if you're a CentOS alt images, you don't gather any RPMs because you don't care, but you do produce ISOs or disk images or whatever. You can just have the steps defined for producing images, and it will just whack Koji with a stick until they're all built. But they will all be coherent, and you can at least tell it to also download them or archive them or publish them somewhere or whatever. Or if you're Hyperscale, you want to produce this and you want to have both packages and images, and you maybe want to have secondary steps or hooks or whatever, then these things are all possible. Or if you're RDO, maybe you only need just the repos and you want to collect up the content set so you can feed into Weirdo, which is literally the name of their testing tool, to actually integrate OpenStack with the full set of content in a reasonably reliable fashion. I know this was actually a big challenge for OpenStack before when I used to be involved in RDO that they could not figure out how to reliably, repeatably, strongly link the stuff that they built on top of CentOS Stream and EPEL and whatever, and make sure that they could tell people this is how we were able to verify things and make it work. Because OpenStack's a big, complex system. That kind of stuff, that kind of data is really important. And they just don't have it. And Overt, which I'm not actually sure what's going on with them, but they could probably find this useful too, because in the past, Overt used to build live images to do from USB Overt hypervisor nodes and things like that, and they could orchestrate the production of branded Overt deliverables for built on top of CentOS Stream or Alma Linux or whatever, because also this tool doesn't care. It is very easy for me to add, say, another build system's compose data format to be able to consume and add that information. So we already support Punji, Bodhi, ODCS, and so on, but if ALBS has a special metadata format that we need to be consuming, for example, it could be very straightforward to add that. And of course, we could just pull yum repos, because that's the lowest common denominator. You have a yum repo, we'll pull it. So that's along with that, Hyperscale SIG.CentOS.org site still needs some work to be set up. Like, again, we literally got the first things working like a week and a half ago. So there's a bunch of things that need to be done, a landing page and a few other things there. But this will be fed. This is actually a prerequisite for us in Hyperscale for OpenQA testing, because OpenQA testing works best when you give it testable units that it can strongly link to. And so these composes that we're doing for Hyperscale will allow us to have concrete links of things that were tested and have test reports that are meaningfully reproducible. So that's kind of it. I don't know if I talked slow or fast enough, but if people have questions, yeah. Questions? I left enough time for questions, so I did at least pace it right. Okay. Nope. I guess I explained it perfectly. All right. You? Okay. Cool. All right.
Thank you.